And if you're in class, you'll see a little thing up here at the top that shows like a Wi-Fi signal. That's how you know we're actually recording. And looks like it's all set up. Well, welcome back, everyone. Again, I missed the seconds hand on the clock over here. We're just gonna wait out the clock, start directly at 2:30. But if any of you have a question or a comment, don't hesitate to interject. Otherwise, we're just kind of meditating for a minute. Hey, and that minute's up. I really missed that seconds hand, but welcome back, folks. Looks like class has started officially. Today's going to be kind of a light class, and I kind of indicated over an announcement about how it's going to go. The first kind of big confusion about this kind of class is that we're split. Half of us in Zoom, half of us in person. And just to give people on the Zoom side about what it looks like, let me show you what my controls appear. This is easy to see in class because we have our projector up here, so everyone knows what it looks like if you're attending in person. But if you're attending over the Zoom call, my controls look like this. Let me hide that for the moment. This is probably the best way to show it, just a quick screen grab. So this is my screen. I have the annotation tool up on the left. On the right, I'm looking at the participation window here. And if you're coming in through Zoom, anything you do along the lines of you could use your raise your hand, maybe a thumbs up or an X to kind of indicate responses. You can participate in a lot of different ways. Voice is usually preferable, or you're welcome to participate through chat just fine. It's tricky for me because I don't have the best attention span, so I have to notice a chat comes through. So if it looks like I'm just ignoring your chat, it's not intentional. And anyone in class over Zoom or in person can just say, hey, Mike, you missed a chat, and we'll read them right out. Another thing that's really tricky about these kind of hybrid classes is the camera I'm using is so-called L camera down here. They're getting kind of old. And the microphones were never that great in the very first place. So sometimes if there's a question or a comment in class, the microphone probably is not going to pick it up too well. That way, sometimes I'm just going to repeat what you directly say just so that everyone can hear it. It gets kind of annoying, but we'll get used to that. And if I, for some reason, just forget and someone said something in class and you're participating through Zoom, don't hesitate to just say at any point, interject, I couldn't quite hear that. And we'll make sure to kind of walk it back, make sure everyone heard what the question was. It's awful to get an answer and not know what even the question was in the first place. And that keeps us on the same page. Again, it's kind of tricky having a hybrid class like this, but we make it work one way or another. Any questions or comments at the moment? Okay. And again, another thing that's tricky about this kind of setup, again, imagine this is my screen along the green border, is I don't actually have enough screen real estate for this window whatsoever. I just close it out. In fact, watching myself as I try to talk is a huge distraction anyway, so that doesn't help me. You're not required to be on camera or anything like that. So usually what I'm looking towards is the right panel for your kind of feedback you might give. And again, using either voice chat or voice or directly chat is a great way to participate. So let me close this out. So I'll usually have the screen turned to about this page. And for people in Zoom in class, is this zoomed in enough to see clearly? Okay, how about for people in Zoom? Are you able to see the text and everything like that clearly from your end? Awesome, I'm glad to hear that. And yeah, that thumbs up is a great way to participate. That way I just know that you heard what I said. And sometimes you'd be surprised. I've done a Zoom class where about 20 minutes in, someone said, by the way, I can't hear you. So any kind of thing you might indicate to know that, to help me know things are working out is a massive help. So I appreciate your participation and feedback in that kind of way. So on the menu today is we're going to really briefly go over the syllabus, some of the ways this class operates, talk about the course materials, how to turn in homework, things like that, see how the class progresses. If you've taken a class from me before, it's pretty much the same kind of setup, so some of the stuff might be kind of boring. And then we'll spend some of the class getting into the very first section, section 1.1. We'll probably delve into a few examples, but we're not trying to make huge headway. So mainly this is kind of an introduction and taking questions kind of day. So here's the syllabus. Let me pull it up. I already have a revision on this, but nothing too major. I changed the room where I'm doing office hours in. I felt like if I have a mixture of in Zoom students and in-person students, this is probably the best class to do office hours because then I can just use the technology in this classroom, the Al camera technology, and not worry about accidentally ignoring people over Zoom or ignoring people in person if I had a headset on trying to communicate like in my office. So that's the minor revision on the syllabus so far. Otherwise, a lot of the stuff we're not going to read out line by line because everyone knows where we're at. You made it to class today, so good on all of us. Contact information is definitely important. I think it's rude to not give your phone number, but this is my phone number. I don't check my phone a lot, so this is like a non-critical way to contact me. You can contact me by a phone call, text, things like that. But usually my phone is silenced, and the easiest way to get a hold of me is directly through my email here. This one's kind of tricky. Usually I think people accidentally send an email to the Jacob SON. So watch out for that E. I don't know who Mike Jacobson with the ON is. You definitely don't want to give him information about your questions or things like that. So this email is used actually quite a lot. Even if you're in the in-person section, I use this email for any questions you might have. Sometimes this becomes a pseudo office hours format in a certain sense. So whatever section you're in person or online, if any kind of questions come up, maybe it's a homework question, maybe it's an exam question, anything whatsoever, feel free to use this email a lot. I'm pretty responsive on it. I'm a fast typist. I feel like this is a great way to connect with students, particularly if you're online and even in person. This usually works out pretty well. And to just emphasize how much you could use this, suppose you're doing homework in this class. Let's just pretend this is a homework assignment, even though it's the syllabus. You're doing homework in the class and you get stuck at any point. Sometimes people take the option to just scan their work they're at, maybe write down a couple comments of what they're stuck on, and send it directly to this email right here. I'm very happy to work with you in that kind of way. I can mark up your answers, that kind of stuff with a digital pen. And this becomes something that I use quite a lot. So in other words, never hesitate to reach out, even if you're for some reason working at 4 a.m. Send that email the moment you have that question. Oops, let me put that away. The moment you have a question in your mind and you're near a computer or a cell phone, it's probably the best time to write that email. I typically check my emails starting around 7 a.m. up to on like today's Tuesdays or Thursdays around 1:30. Mondays, Wednesdays, I'm checking my email to up about 3:30 before I head to work. I'm usually available by email almost all day on Friday. I usually do take the weekend off, but I'll always be looking at the email, responding to critical things that might be happening. So that's the best way to get in contact with me. It overlaps with office hours. For office hours, these are strictly walk-in. So Monday through Thursday, I'll just be available 4:15 to 5:15. That might not be the best time for everyone. Some people might have class or work directly at that time. And that's one of the reasons I encourage you to make liberal use of just directly emailing as well. I'm also available by appointment. If none of those options work, just send me an email. We'll get something to work somehow, some way. But any questions at the moment so far? Okay, one habit I'm trying to get into, I think I say this every semester, but it's more of a reminder. I'll usually leave about 5 seconds of dead time after I ask a question, just to give everyone a chance to respond, think of the question, especially if you're over Zoom, it might take a moment. You're also fighting latency to get your response out, especially if you're using chat. And if you're using chat and you have a message that you're typed out and I start to move on, still just send that chat. There's no harm in interjecting. Sometimes pumping the brakes on the class and getting your questions out is the best thing you can do for everybody in the class. So let's keep on going through this. Other major part of the course I want to talk about is the textbook. This is a highly traditional class. We're going to actually use a paper textbook, or you might have a digital copy. That'll work just fine. And I'm really open to whichever edition you might be working out of. The 6th edition is the most recent edition, and all my course lecture notes are based off of it. But honestly, the rest of the editions, maybe not the first, second, or third, those get pretty old. But from the 4th and the 5th, these are very equivalent textbooks as well. So I encourage you to get a textbook as soon as possible. The ISBN here is to the 6th edition, but you can find really pretty dirt cheap a 4th or a 5th edition as well. It's a great way to study. Reading this material is a great way to learn linear algebra. We try to throw lots of information into the notes, but really there's only so much we can put on here. Class would have to be not 75 minutes, but more like maybe 175 minutes if we're trying to put in every single element that's mentioned in section 1.1. So some of the ideas are left to the reading, and I'll always indicate what sections to read, and if there's content from a section to be skipped, I'll indicate that as well. Again, these editions are really highly equivalent, so either one of them are going to work. But also causes a problem because I think publishers do this as kind of a self-defense so that you don't buy an old edition. They change the homework exercises from edition to edition to edition. And so to counteract that, on our first assignment 1.1, if you click on this, I'm always going to import a PDF. If I have to type these out directly, sometimes I will. Other times these are a screenshot. I'm not saying you have to do every single one of these problems. I'm just saying this is the actual problem set from the most recent edition that you'd be doing the homework problems out of. So this is that last section. And for the homework assignment, shame I can't show it here. I'm still getting used to Canvas. Let me click on this again. You're just doing these exercises, 3, 8, 9, 12, 13, 19, 26 on page 10. If you're on an old edition, just ignore that part. Just go to the PDF here. If you have the most recent edition, you'll have no need to ever click on that. You'll just go to your actual textbook. So that's what's going on with the textbook. You should be able to save a lot of money. If you like the newest and shiniest brand new 6th edition, they are costly, but if you've already got them and you're happy, you'll be just fine. If you bought the most recent edition, you might, and you're not in the ISU book bundle, if you bought it with your own money, you might change your mind and get an older edition, and that would be just fine. Well, any questions so far, folks, about the textbook or the homework at the moment? Okay, I have other interesting things here about a calculator. We do have a calculator policy where we're just using a basic scientific calculator, not a graphing calculator and so on. These are recommended models, but anything that's a basic scientific calculator would work just fine. And if you have a calculator you like and you're just not sure if it's a good one, don't hesitate to just take a picture of it, send me an email, and I'll be happy to look into it with you. Just click all these things away. Let's get down through the homework. We looked at it briefly. The homework is going to be directly associated. Sorry, not sure how Outlook is not going away. Not sure what I clicked on there. I must have clicked on my email address. That's what it was. But the homework is going to be directly associated with each section. The moment we complete section 1.1, this will probably be on Thursday, that's when the due date for this is considered officially assigned. So these are in flex. If we decide we need to take a little bit extra time in section 1.1, maybe we ended up finishing it next Tuesday, the due date will always be 1 week away from where we complete the entire section, 1.1. And by completing the entire section, what I mean is, let me hide that for the moment, completing these notes right here. So this is pretty much how the course is going to progress on a day-by-day basis. I'll have the notes posted here. I've opened them up as a Word file, and we just work on them as a class together, and I'll be saving these into a PDF, overwriting it right here. So if you ever need a fresh copy, go to the blank lecture notes, and you can always download them from scratch. Then the assignments will be directly based off the lecture notes here. And really the best way to be successful in this class is do as much pre-reading as possible. For some people, that might be impossible to do any pre-reading before you come to class. It's all dependent on your schedule. But anything you can read out of the book prior to even coming to class is going to make all these ideas feel like they make a whole lot more sense. In other words, this section is not too crazy, but linear algebra gets really abstract fast. And the definitions that you see in linear algebra, particularly say chapter 4, is the first times your eyes have ever seen that definition. It's really actually hard to internalize this information right during class. If you even just picked or took a peek in section 1.1 or some of the later sections in the book before you came to class, maybe just skim through, look at the definitions, it causes a lot of traction on your brain. It causes kind of a structure. And if this is the second time you've seen this definition, it makes a whole lot more sense. Your subconscious is possibly working on it all along until before you come to class. So if you get in the habit of reading before class, or maybe after class if that's just how your schedule permits, then working on the homework assignments, you want to work on the homework assignments at a high level. It's going to prepare you really well for the exams. Reason for that was supposed to be the syllabus, is my exams are based quite heavily on what you actually do as a homework set. In fact, when I go to write an exam, I look over the problems that I assign in those sections. I don't write down the verbatim problems, but everything is along the similar kind of vein of what you really did in the class. So the harder you work on your homework, that means really the better you're going to do with your exam scores. These are extremely well correlated. And the final exam is really just more of a formality. This is the only exam that I would curve in the last part of the class. And it's really just based off how the course average goes. By the time you finish exam 3, the final exam is not meant to move the entire class average much. So if I grade a final exam and I notice that our class average goes down by like say 10%, it tells me that I ought to give a curve to the final exam. It's probably more tough than it was meant to be. Well, any questions so far, folks, with the homework at the moment? Okay, this has been about 16 minutes of straight talking, but we're getting through it. One of the things that happens to me when I come back from a summer break is it's easy to feel a little bit more anxiety than normal because, again, I haven't been working for 4 months. I think I start talking really, really fast. So if any time it sounds like a word salad or you're not sure what I just said, don't hesitate to just clarify. It's never rude to just say, hey, Mike, I'm not sure what you just said. That's always completely fine. But to give further advice on homework, I have this information that's written down here. Working through the homework in groups is highly encouraged. That can be sometimes hard, but if you're in class, you might see people you know and that can form natural groups. Over Zoom, you can see your fellow participants and you can always directly message them to see if they would like to form groups as well to solve the homework assignments. Only thing that I expect is that you're writing down your own solutions. That's what I mean by turning in your original work. That way it's actually really helping you on preparing you for their exams. If you're just copying another student's work, then you might be in a critical position, finding studying for exam 1 to be exceptionally hard. On homework, we do have to require step-by-step solutions, but there's a real purpose to that. When you're doing the exam, the step-by-step solutions are expected as well. So think of every homework problem you solve as really kind of an exam dress rehearsal. The same problems, not exactly the same problems, but very, very similar problems are going to show up on exams again. So you want to get in the habit of just writing out your problem solution like you would on a real exam setting. I'm going to give a lot of attention to the work you write in, provide lots of feedback, with the understanding that the feedback I'm providing you is, if this was a real exam question, this is the stuff that you would have had to include in your solution to get full credit and those kinds of things. So also when I return your homework, pay close attention to the feedback as well, which is hard because it feels like you're doing homework twice, but take a look at that feedback. It's meant to guide you on what might be missing to further support you on your exams. Also, there is some extra things that go on at the end of the course. Let me see if I wrote this out. At the end of the course, I'm going to drop the lowest 2 homework assignments. Sometimes this gets bumped up from 2 to 4 based on other extra credit opportunities that happen throughout the semester. So don't think of the homework assignment as extremely high stakes. Think of it as you're preparing yourself on the exam on every homework assignment. By the time it comes to actually doing the exams, we'll be down here for exam 1, for example. Your homeworks that's been returned will be a great resource to prepare you. I'm also going to be posting additional problems here and other study materials to help out along the way. But that takes us to the math department policy. One thing that's kind of rough about a class like this one is, even though if you're on the online section, we do require in-person exams for every student in this section. So if you're in the in-person section, exams are just going to happen in the classroom during the regular class time. For the online section, I'll be coordinating with each one of you individually. I'll be sending out emails on Friday to determine your preferred campus. Some people are possibly going to test in Idaho Falls Testing Center. Others are going to be in the Pocatello Testing Center. But if you're closer to, say, University of Idaho in Moscow or maybe Boise State University, I'll work with you directly in getting you into a nearby testing center. And there's also extreme situations that come up. Sometimes I have students, like in one of my classes on Monday, I have a student in Rhode Island. I have other students in Utah. Last semester, I had a student in California. It's actually not hard to coordinate and get people into a local testing center. So if you're a very far remote student, nowhere near Idaho, don't fret. The in-person examination requirement is still firm. This comes from the math department themselves, but I'll be coordinating with you to make sure we find a reasonable testing center to get into. But I think that's my whole spiel on homework and exams. Any questions whatsoever, folks, at the moment? Okay, there's a lot of other stuff here that you could read through if you like. We'll come back to some of this information as we get closer and closer to exams, so we're not just reading the entire syllabus line by line. The day-by-day schedule is important. I find in this class, I usually keep pretty close to the day-by-day syllabus. But again, aside from the exam dates, exam 1, 2, and 3, and the final exam, those are the only ones that are firm. And if we decide we needed just to take an extra day in section 4.1, this is probably the most abstract section in the entire semester, we'll take that extra day. So you can always come back to class with questions on a prior section, questions on homework, things like that. That's a great way to spend class time. So part of our pacing is informed by you, the student, and this is just a structure that I usually try to keep to. Notice we don't have reviews before exams. This is a tight schedule. They have a lot of mandatory material we do have to cover. And that's why I do provide extra support here on the type of reasonable exam questions so that you're very well informed on what to expect. My exams will always happen on a Tuesday after a weekend so that you'll have that extra time as well to prepare. I did mention I usually don't reply to emails on Saturdays and Sundays, but if you're studying on a Saturday or Sunday ahead of, say, exam 1, I understand that that's a critical week. I do get on my email, pay much more attention to it, and respond even on the weekend when we're coming up to any one of these exams. So this is our day-by-day syllabus. Below are lots of university resources. Usually students have seen quite a lot of these by the time you're in a class like this one. So nothing's too updated here. I just like to point out, if you feel like some of these are kind of vague, they're tremendously important. If you've never read this one before, it's a good idea. If you've never read the Title IX federal law before, that one's a critical thing as well. And there's other stuff like services. This is just a nice statement on success. But I like to point this out as well in all my classes. This is for every single class you take at ISU. Just also know you have rights as a student. If anything is happening in your class, whether it's in class, outside of class, any kind of interaction just doesn't seem right or fair, then there's always an avenue for addressing that some way, somehow. And that's what this bullet point right here is all about. Dr. Ralt is our department chair, and we have a new dean of the College of Science Engineering, Dr. Widman. So these are points of contacts that you could use. So again, this is not just for this class, but any other class as well. If you're in a different department, some of these emails might be different. But that's the whole reading through of the syllabus. This class, it only took, let's see, 23 minutes. My other class, I think it took 50 minutes, but maybe that's because it was Monday. I was getting used to this stuff. Any last questions or comments at the moment, folks, before we wrap up the syllabus reading? Okay, that's a lot of information talking straight through like that for 23, 24 minutes. So the good news is this all gets recorded. If you ever have to come back and see what we said at any point, it's going to fall right over here. A couple things about this class that applies to everybody is I don't have an attendance policy. And so keep in mind, it's really attendance on your honor. Do your best to make it to class when it's reasonable and feasible to do so. If something happens, if life is just getting crazy, if a car breaks down, if your internet goes out, the class is always going to be recorded and the lecture recordings go here. In fact, I've done this class multiple times. If something goes wrong with the recording, I can just upload a recording from a prior semester. It's going to be the same material. That's just an unfortunate thing to do. I'd rather do the current semester's recordings. Let's see, other things to mention are, let's see here. There's some optional articles on some of the value of linear algebra. And this is just a generic study guide for studying really any kind of math class. It's also a great resource for studying other classes, such as like calculus, differential equations, trigonometry review stuff is inside here as well. So this is the legendary, I don't know how legendary it is anymore, but back in the day, early 2000s, Paul's Online Notes was a lifesaver to a lot of people. It looks like a really old website because it is. He hasn't updated it much, but it's chock full of really, really great stuff. I just have it bookmarked to the How to Study Math page. On the sidebar here, there's loads of other great materials as well. So that's pretty much the structure of the class, how we're going to proceed day by day. When you come back to class, say on Thursday, I'm just going to have this scroll down to roughly where we're at in the class on Canvas. You'll know exactly what section we're on. Any work we do today is going to be re-uploaded right here. And I'll be uploading blank lecture notes, new notes, just on a day-by-day schedule. I don't like to upload everything because I notice every time I go to teach a class, I do some reviewing my own notes at the start of the day. I often make some small changes here. Sometimes there's typos needing correcting, and I'd like to get all those corrections finalized before I just throw the notes at you. So I'm going to be posting everything piecemeal on a section by section, day by day basis. So I still have Outlook down here. I'm not too sure how to make that disappear. Who knows how that's coming up, but anyways, here's where the course starts finally in earnest. Chapter 1 is linear equations and linear algebra. What we're really going to be looking into is systems of linear equations and their solutions. There's really a lot going on in linear algebra. It's a pretty vast interconnected subject, and it's unusual as far as math classes go. For example, if you've taken, say, a calculus class, maybe even a differential equations class, you'll notice these classes are highly, highly computational. Our classes too, but something else starts to take over. We start to talk a lot about definitions, theorems, and arguments between them. So a lot about what happens in linear algebra is how all the definitions interconnect, how all the theorems work together. And there are a lot of definitions in linear algebra. It's something that we're going to get used to. We'll start to see when we're in the further sections, like sections 1.5, 1.7, and so on. There are a lot of vocabulary actually to master in this class. So we'll always go carefully through these definitions. Each definition deserves an immediate example, and here's a natural starting point for the class. Makes sense if this is linear algebra, we should define once and for all what is a linear equation. So by linear equation, we just mean we have an equation in variables, x1 dot 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 just says and so on, through xn. We need to do that because even though we may be looking at 3 variables, maybe 5 variable systems, in general, our subject is for any number of variables. In actual practice, there could be hundreds of thousands of variables in our system of linear equations, potentially even millions, depending on how much we're going to really be studying in a data set, for example. So the variables are x1 through xn. The coefficients of the variables are the a1, a2, an, so they're presented here. And the right-hand side b is just an ordinary coefficient as well. It says here in the notes, these coefficients are real or complex numbers. But our focus of linear algebra, we're not doing super advanced linear algebra, is going to be primarily the real number system. So we're going to almost 100% of the time in this class look at just real number coefficients. I shouldn't say almost 100%. I believe it really is 100%. The more linear algebra you take, the more you start to delve into the complex number system with complex coefficients. But again, this is an introduction to linear algebra. We're not trying to do the toughest parts of the material right away. So usually the coefficients are known. Our job is to specify what is xn through x1 through xn that satisfies the system of equations. This is just one equation, but when we say a system of equations, we mean multiple equations like this one, and we're trying to satisfy them all simultaneously. So example one is kind of a light exercise, just a real fast concept check. We want to determine which of these three equations are linear. And if the equation is nonlinear, we'll circle the portion that makes it nonlinear. Well, let's start off on this one. What would you all say to this? Does this look linear or nonlinear? Any others for nonlinear? Well, it turns out this one is actually a linear system, and it's kind of weird, right? It doesn't even have the right format. So these things are kind of tricky and vague. It's part of the reason we do spend a lot of time in linear algebra to get a handle on these. And it seems like an absolute lie if you look at where the red dot is. My linear equation should look like this one, but the reason there's a cop out here is it says that can be written in that kind of form. So in other words, if we reorganize this equation, rewrite it as 4x1 minus 5x2 minus x3 equals 0, it takes the required format. So these are all basically trick questions, which is kind of awful. This does come back as an exam question, but by then we're prepared. We're going to see this kind of come up in the homework as well. So it has everything it requires. The coefficients are real numbers. They're 4, -5, -1. The right-hand side is 0, a real number as well. And critically, nothing is happening to x1, x2, x3, other than it's being multiplied by a coefficient. So that's what makes this one here linear. Again, it's kind of an awful trick question just right out of the gate, first problem of the entire semester. Does that make sense to everyone on what's going on with this one? Okay, let's try it out again on part B. What would you all say to this one, linear or nonlinear? I agree. This one is absolutely, let's do some color coding on this one. Nonlinear. Now we have to circle the portion or portions. Really, if this was an exam question, if you circle just one part, that's okay with me. But what parts do you all see that makes this nonlinear? Absolutely. So this right here is a problem. Cosine is a function, and now x1 is the input to that whole function. That's completely unallowed. At worst, we might have something like tangent 8 of x times x1. That's okay. x1 is not inside the tangent function. Tangent 8 is just a number, a funky number. It's irrational. This is an abstract form of writing a number. Well, that's absolutely allowed. This is not. So watch out for something like this. No variable can be inside a function. And if you're a very, very precise-minded student, that's great. This is not a completely accurate statement. Some functions are nice, like f of x equals x is the identity function. It leaves x unharmed. That's actually allowed. What we really mean by this is a function other than the identity mapping like this one, and cosine x changes x in a very big way. So that's the problem right there. So that's one part that makes it nonlinear. But there's a second part as well. Anyone spot the other problem in the part B equation? Exactly. We cannot have variables multiplying each other. It's just as bad as taking a function, a non-identity function of a variable as well. So this in and of itself is a problem. Variables cannot multiply each other. And I don't know if this is being picked up, by the way, as a side thought. I don't know if this is being picked up on the Zoom camera. Let me know if this becomes a problem. But these computers here are new computers. I can hear the fan really whirring up at some points as we go through this. Hopefully it's up for the task. It got kind of loud yesterday on Monday's classes, but we'll see if they break down and make it through the semester or not. Let me know if it ever becomes a problem on your end. So first one was linear, second one was nonlinear. Anyone see what's going on with part C? Is this one linear or nonlinear? Absolutely. Good call, folks. This one is linear. It looks pretty bad. This is practically a trick question, much like part A. But look what it's got going for it. No variables are multiplied whatsoever. Sure, we have weird stuff like tangent 8 in the mix, natural log 5. Those are just ordinary real numbers. Like we said, they're rational, they're written in an abstract way, but that is absolutely allowed. So the coefficient here is a 1, then a -1, and tangent 8, natural log 5 are real numbers which qualify. So this one is linear as well. So this is a kind of a fun exercise just to see how literal can we be on a definition. For example, part A again is a big trick question because the equation is not in its standard form like we see up here, but everything we say in this definition has to be taken 100% literally. Oftentimes people say in mathematics, we mean what we say and we must say what we mean all at the same time. And this is an example of that right here. But there are times when we write down mathematics, we're not always 100% precise. I said no variable can be inside a function, but what we mean is non-identity functions like cosine, natural log, x squared, and so on. So these are the examples of linear equations on the left. And watch out for any of this kind of business like we see here on the right. Well, any questions or comments so far, folks? Okay, and at this point, you pretty much have a pretty good idea of how class is going to proceed. My lecture notes, which I encourage you to either download or print off if that works better for you, or just have ready to go when you look at your notes again later on, are basically gigantic worksheets where we fill in information, go problem by problem, add some comments, explore the definitions as we go. If there's any kind of issues, particularly if you're coming in through Zoom and things don't look like they're zoomed in far enough or anything like that, please let me know. Ideally, though, you're looking at this through, say, a tablet or a laptop. Viewing this through a cell phone, I think, would be really pretty hard, unless you have just really excellent vision, I'd say. So here's our next definition. We're not into the big core definitions just yet in section 1.1, but we're just building our way up to those structures. We looked at what a linear equation is, and a system of linear equations is just linear equations taken together where we're looking for a solution. It's going to be a list of numbers, S1 through Sn, that once we substitute it in for the variables in the equations, x1 through xn, we get each equation true simultaneously. So a solution set to a linear equation like this one, this is a system of linear equations, is a value for x1, x2 that is going to make the first line true and the second line true simultaneously. And this is a pretty simple linear equation, right? This is a system of two equations, two rows here, in two unknowns, that's the x1, x2. It's fast to solve by hand. Honestly, you don't need linear algebra to solve this thing, but we're building our way up to the bigger equations. Already in this notes, you're going to see the power of linear algebra when we get down to something like this one. This one you could solve by hand, but it starts to get really, really tedious. This one you could possibly solve by hand. It's not even written in equation form. That's probably even harder than this one right here to do by hand. Linear algebra is just an extremely powerful tool that takes equations like these, even though this is a simpler one, and gives us a direct process of determining, does it have a solution at all? If so, what is the solution if it's unique? And what are the solutions if there are infinitely many? So first I felt like, let's take a look at the graphical method. This is something you could have done in an algebra class, except that it's extremely dangerous, right? The success of this method depends on my ability to plot each equation exactly and precisely, and their point of intersection to be identified exactly and precisely as well. So if you graph these two equations, I graph them in Desmos, this is what it looked like. I said to solve the system of linear equations graphically, and here it is. This is the solution. already things probably look a little bit weird, right? We're used to an XY plane, but I'm writing X1, X2. It goes back to this definition here where we're going X1 through Xn. We have so many variables, we can't go X, Y, Z. We ran out of letters already if we have 4 variables in our system. So we go like this, X1, X2. This one's going to be the X1 direction. This is going to be the X2 direction. And this whole field is the X1, X2 plane. We have 3 variables and we're really artistic. We'll have a vertical axis. That would be the X3 direction. If you're like demonstrations, it would look about like this, for example. This would be the X3 variable. This would be the X2 direction and going up this, excuse me, X2 direction going to the right. Said it wrong again. Let me try again. X1 direction going to the right, X2 direction going up, X3 direction coming out vertically. But then even after working hard to try to visualize that, what goes wrong in 4 variables? We can't graph these things very reliably any longer. Yet we need systems of 4 variables, potentially 50 variables or 1,000 variables. You could consult the physicist, your local physicist. Space-time reality is a 4 variable system already. So we need generically loads of variables. We're going to land in the XYZ approach and just go with X1, X2 through however many variables we have. So the solution's there, and we say the unique solution is, there's a lot of ways to specify this. It could be an ordered pair. Let's do the ordered pair approach first. We could say the unique solution is check coordinates. The XY coordinates, we're at 3 here. Let me know if I miscount these. It's the first day, stuff happens. In the X2 direction going vertically, we're up 1. So we could specify the solution in that way if we prefer. If we'd like, we could also just simply write, or we may write our unique solution this way. X1 is 3, X2 is 1. Oftentimes we go this route as well. Depends on context and what's more convenient at the time. And we're not going to do this as often because once we get further onto linear algebra, we're going to visualize our vectors differently. Calculus often goes in a horizontal approach using angle brackets. Sometimes we call those position vectors in physics as well. This is more of an ordered pair if we use parentheses. In linear algebra, this is often written this way. We'll call this a column vector as we introduce it, 3, 1. And that might seem a little bit weird, but we're going to see later on that when we have vectors written in a column-wise this way, 3, 1, then full-on matrices, say this matrix down below right over here, there's an algebra against vectors and matrices as well. If you visualize things just right, we see the system of how that algebra works. So there's an actual purpose to writing out this new kind of notation as a column vector. Column vector. So there's lots going on in linear algebra. Section 1.1 is meant to be just kind of a get started with some of the core terminologies, some of the new notations, and so on. Any questions at all, folks, with this very introductory example here? Okay, so we solved a linear system by someone graphed this. I graphed this the other day, and we just eyeballed the solution. This is not a method that we can reliably duplicate. In fact, if I had to do this by hand on a whole new system, I'm probably going to be way off the exact solution, and there may not be any solution. So that's why we need new methods. We're going to see that down below in example 3. But before we just skip onto that, let's look at some interesting theorems and an interesting definition as well. One thing that's nice about linear algebra is that sometimes we call it just really well behaved in the sense that there's a trichotomy. Exactly 3 things, and only these 3 things can happen for any system of linear equations. It's the nonlinear stuff that gets messy. So calculus dealing with nonlinear things is a vast subject when it comes to solving a nonlinear system of equations. In a nonlinear system of equations, you sometimes have to invent a new method for every single new system. There's no direct approach. It's a wild and vast landscape. But in linear algebra, there's total order here in this really strong sense. So here's our first major theorem. A linear system has either no solution, exactly one solution, that's what happened up here, that's the exact solution, or infinitely many solutions. If there is a solution, either one or infinitely many, we say the system is consistent. So let's say a consistent system here on the notes just to convey that. And that's really interesting in a certain sense. For example, if someone tells you I have a system of linear equations and there's exactly two solutions, you get to say, that's impossible, sir. Your system is either nonlinear, or if you found two solutions, there are in fact infinitely many, and that's a guarantee now at this point. It's hard to convey this why if we're in, say, 20 variables, or even just 3 variables. It's not easy to really visualize. That's why we're starting off with just 2 variables here and here. It's a little bit easier to see what's going on with this system if you're constrained to 2 variables. So for example, if we say that there's exactly one solution, this is the plot of the system in 2 unknowns, 2 linear equations. If there is no solutions, here's what has to happen. Lines, let me fix that real quick, are parallel, different slopes. So the graph might look like this. Here's x1, x2. Here's one line. Imagine this is perfectly parallel, the next line. So this system right here is automatically inconsistent. Because if there was a solution to the system, the lines had to have intersect, like in this scenario here. So really, this is kind of just a rundown of ordinary algebra from back in the day dealing with plotting lines. But this same idea carries on to 3 dimensions, 3 million dimensions, it doesn't matter how many. This is a fact of every single system of linear equations, which makes it a very useful and deep fact, more than it seems right on face value. Anyone see what must be going on then if there are infinitely many solutions? What has to happen for that to be the case, our reality? Exactly. They're parallel and they're overlapping. Essentially, we can make that happen at any time by going like this. I'm going to fix the notes on here, but if I went plus x2 equals 4, well, if we call that a system of equations, it now has infinitely many solutions. And it's easy to see why, right? It's just the same equation duplicated. We might hide that fact by going 2, 2, 8. It's slightly disguised that this is infinitely many solutions, but if you look really close, equation 2 is just double equation 1. It has infinitely many solutions just from that fact alone. Let's put it back to the way it was, though, so the notes don't look crazy. So just to convey that last thought, infinitely many solutions looks like this. Just for the sake of completeness, let's get this on here as well. Here's x1, there's x2, and you have one line. I'm not sure how to convey that really accurately without a note. So this is overlapping. Parallel lines, because every point on this line overlaps with 2 lines. Every point on the line is also a solution. But because there are solutions, we call this consistent. So we only say inconsistent anytime this happens. There's just no solutions whatsoever. Well, any questions at all, folks, with the definition or theorem? Yeah.
So the part, is that right?
Oh, it's not right. Thanks for seeing that. Good eye. Let's put in a really fast correction here. It would have to be, let's see, other dimensions that could work. Yeah, 3 dimensions, you have skew lines that could have all sorts of different directions going on. But you're absolutely right. Good eye on this. This should have said lines are parallel, same exact slopes. Let's go with exact slopes to really convey that. Thanks for saving the notes on these. One thing to keep in mind is the YouTube errors are forever unless we get a correction. So I always appreciate it spotting anything that looks weird on there. Does that make sense to everyone, that correction? Okay, so we can never fix the YouTube, but if you ever notice that we saved notes onto Moodle, and there's just something wrong, that's one thing I can correct. And if I ever make a correction, I make it stand out by saying revised on it so that we know what the correction might have been. Thanks again for spotting that. It's always interesting what kind of weird errors that can come up. Other times, sometimes it's just a weird micro sleep I might have made in class and just wrote something weird. Other times it's just a genuine error. And I appreciate everyone's careful attention to keep this kind of information straight, especially when we're learning a whole new subject. That's really helpful. So this tells us what to expect with any linear system. And let's make this next example 3 our last problem for the day. I didn't want to get too far into the notes since first week is kind of overwhelming and we talked like 23 or 25 minutes straight about course materials. So we'll end on kind of a gentle problem right here, example 3. All the problems, examples 1, 2, and 3 are pretty much a big introduction of what we're getting into in this course. Example 3 is the bigger introduction in a real sense. Think back to what you might have done back in an algebra course, say pre-calculus or college algebra like we used to call it. Sometimes you had to do loads and loads of long division. You might remember that, you might have been traumatized, and it could be foggy in your mind. But then what you see are new techniques that come out, so-called synthetic division. People decide if I'm going to long divide by ax plus b over and over again, I need a faster approach, and synthetic division is a way to just make it all faster. The idea about synthetic division is the variables did not matter. It's what happens to the coefficients that really matters. And this is what dealing with solving solutions linear algebraically through augmented matrices really looks like. So we're going to solve this one by hand. It's the same one that was graphed, so we know, actually, is it the same one? Let me double check. Yeah, it's the same one, so we know what solution to expect on this. Just because this is a new concept, we're going to do it in 2 different ways. The algebraic method, which has a couple approaches all on its own. We'll compare it against our brand new methods that we're going to look into further on next Thursday, row reduction of an augmented matrix. Let's start right here because this is the part we're all excited about. Like I mentioned, if I want to solve this system algebraically, I don't even care about the variables x1, x2, and that just sounds weird already. Algebra sounds like we care about the variables, but this is all I really care about. The essence of this system of linear equations are 1, 1. Where did I get that from? I'm fixating on column 1 right here, and it's 1 times x1 really, 1 times x1 here really. I'm just pulling off coefficients. Let's say that as a definite statement. This is the idea of synthetic division. It's the major idea of linear algebra. Pull coefficients. I'll say that statement a whole lot in this class, probably over 100 times once we're done with the entire semester, because it's just such a common thing to do. Column 2, if we pull coefficients, well, it's 1 times x2, so a 1 goes in. It's a negative 1 times x2, so a negative 1 goes in. And now the right-hand side is kind of special. The augmented part of the matrix is the fact that we have equals to. We sometimes convey that equals with a dotted line. And the right-hand side have a particular importance, 4 and 2. So there it is, folks. This is our augmented matrix. That dashed line reminds us that it's augmented, which reminds us everything to the right of the dashed line are the right-hand sides of both equations. Sometimes people convey even more stuff on here. And the redirect this arrow. Sometimes people might write lightly x1. Just as a reminder, these are all coefficients belonging to variable x1. x2 is a reminder, these are all coefficients belonging to x2. So this is how we would start off in linear algebra. If we were an ordinary algebra class, this is what we would do. Write in x1 plus x2 equals 4, x1 minus x2 equals 2, and this is the elimination method where I would just tally both equations. Literally just add them up. Column by column, we'll get 2x1. This is the miracle in the equation. Column 2 adds to 0. x2 minus x2 is 0. And on the right-hand side, we would get 6. So 2x1 equals 6. It's a third brand new equation, but any combination, linear combination of the prior equations gives us a new equation with the same exact solution set. So nothing's lost if we rewrite x1 plus x2 equals 4, 2x1 equals 6. It's a totally new system of equations, but the solution set from here is equivalent to the solution set down here, as long as we make the right kind of operations. Those operations later on are going to be called the elementary row operations. What we're really doing is introducing just precisely what those are. So let's do it all over again over here. We want to write down that this augmented matrix is related to another one. We can't write equality because matrices are only equal if every single one of the entries are identical. So we write out something different. This symbol right here is the row equivalence symbol. You'll be asked to use this when you write down row equivalences, showing your steps in homeworks on exams. We can't write out equality, but if you wrote equality on every single one of your problems, I'm not going to nickel and dime you on every single problem. You might just lose points once on the first time. With a reminder, we need to use this symbol here. The matrices are not actually equal. It does become a problem because we'll have to use equality signs later on in chapter 2 when we're dealing with matrix algebra. So we write down this. We're going to do a row operation. The prior augmented matrix is going to be row equivalent to this new one. So what we're going to do is maintain row 1, go 1, 1, 4. And notice how nice it is if you could just add row 1 to row 2, because something goes away, coefficient disappears. This is the major thrust of linear algebra as well. We love matrices with as much zeros inside of it as possible. In fact, it sometimes feels like a lot of the theorems are just trying to get you to that format with lots of zeros in your matrices. I'm going to add something new here just to specify what I'm about to do. I'm writing it in this orange color just to say it's optional. You don't have to put this on your homework set unless it's helpful to you. Our author writes this out as well, so this could be helpful with the reading. What we're doing is a row replacement. Row 2, which we'll write as capital row 2, gets replaced with, the whole right arrow is just going to be a synonym for gets or gets replaced with, row 2 plus row 1. So we're literally going to take row 2, add these two together, and put in the replacement of that. So if I add these two together, I'll get 2 on this column, drop it in. Add these two together, I'll get 0 on this column, drop it in. Add these two together, I get 6 on this column, drop it in. Notice I didn't put the dot, dot, dot here. It's really just a stylistic choice. I'm going to bring in the dot, dot, dots once I get to the very last step. If you'd like to put it on every single step, that's completely up to you. Again, it's more of your preference at that point. It's good to have it at the beginning to remind you it's augmented. It's good to bring it back at the very end, at least, just as a further reminder. Yeah, go ahead.
Is it important that you save the first equation and you take the second?
You could have made that work too. Yeah, there's loads of routes to the same exact solution set. So if you went a different route, say row 1 gets replaced with row 1 plus row 2, that would have been a perfect operation as well. So lots of different roads all lead to the same exact solution set. Other questions so far? Okay, let's pause right here and notice what's just happened. This is 114, 114. This is 206 for coefficients, 0 because there's really a plus 0x2. We just don't write that in because it simplifies immediately, right? 0 times x2 is really just a 0. And plus 0, I mean, why even write that at all? There's no change there. But we still read it as a 0. So that's 206 that shows up here as well. So the same exact steps we take algebraically, which do take a lot more writing to put down on paper, we're doing here the exact same algebra. So that's the tie-in with long division versus synthetic division. This is exactly what synthetic division is trying to do, get you directly to the result, quotient remainder, without fussing with all the details that actually didn't matter. This is the algebraic structure of how you get to the solution set. And this is just a bunch of unnecessary names typed in that we didn't necessarily have to really look at in the first place. So let's continue this analogy, take it to the solution set. This will be our last problem for the day, like we mentioned. Any questions at the moment to this stage? Okay, at this point on the left, again, we're doing it in dual just to see how it looks on the left and on the right. On the left, you're basically done, right? You just divide by 2 here. X1 is 3. You could substitute it back in and you have your answer. But I'm going to do it in a slightly more painful way just to mirror what we're doing on the right to see how these steps work. So first thing we would do is divide by 2 here. Take 2x1 equals 6. Divide by 2. Divide by 2. Results in a new equation. X1 is 3. So that means we can rewrite a whole new system of equations. I'm going to keep equation 1 as the same. X1 plus x2 equals 4. And then over here, x1 equals 3. So that's what it would look like on this statement so far. Again, algebraically, you'd be done just almost instantly at this point. Put 3 right here, subtract x2 is 1. But now on the linear algebra side, here's what the operation would look like. We would say this row equivalent is, this system is row equivalent to, oh, and I missed a chat, sorry about that. Angie says, we can't hear the questions people ask. Can you repeat them so we can hear? Yeah, absolutely, sorry about that. That's gonna take a couple reminders. I'll get better at it as the class goes. And I think the question was, so thanks for asking about that, was, did I have to get a 0 down here, or could I have added this row to the top to get a 0 up here? So that was the original question. Again, thanks for correcting the record on that one. And the answer was yes, you can get the 0 in either way, and it would have worked out. Other questions at the moment? Okay, and no worries in class. Again, you have to have a really deep and loud voice. You're practically yelling if you're in the back row to really be picked up on the Zoom camera. Our technology is just getting old and it was never that great of a microphone to begin with. You might have noticed if you took classes during COVID, Zoom cameras were really awful microphones all along, but we'll get through it as a class for sure. I'll always probably need some extra reminders if I ever miss something not getting picked up well. So thanks again, Angie, for that question there. But now let's go back to our system here. We're not doing anything major. We're just reproducing algebraically on the right what we conveyed on the left here. We just wanted to divide row 2 by 2. Our shorthand might say row 2 gets replaced with row 2 divide by 2. Nothing else is changing. We're just making the change on row 2. So we copy in row 1 exactly as it appears, 1, 1, 4. Divide row 2 by 2. We'll get 1, 0. 0 over 2 is still 0. 6 divided by 2 is the 3. Now we're nearly there. We have a nice 0, and we like seeing the 1s as well. If I could find a way to just eliminate this entry, we'd be home free. Same idea on the left-hand side. Sure, I mentioned you could solve this by plugging a 3 right inside there, getting your readout for x2 when you solve it. But you know what else you can do? You can multiply this whole equation by -1. There, we just did it. We multiplied both sides by -1. You could retally this. X1 eliminates when you add this up. So 0x1, x2 goes over here. The tally on the right-hand sides gives you x2 equals 1. That's the full elimination method. You're trying to eliminate variables, getting an answer for each variable individually. And this is, let's not use that color. Let's use this for the solution. Our solution, x2 is 1, x1 is 3. I think I recall that from the graph. We were on the right track there. Same idea on this one. I can take this entry right here, trying to choose a color. Later, we're going to use this language more and more in upcoming sections, but I want to pivot off this entry to eliminate the entry above. There's a lot of other things I could do. I could just swap the rows if we really wanted to, but I don't want to take too much time on this. I want to really mirror what I'm doing on the left, on the right simultaneously. So let's mirror that step. I'm going to take this exactly as it stands, right? That the last matrix is row equivalent to the following. Let's write what we're trying to achieve. I want a 0 right there, which matches there's a 0x1 on the left side over here. So we're going to say this time it's row 1 that gets replaced with row 1 minus row 2. There's a lot of ways to do this. Again, this is just a way to get there. My instructions, orange means it's optional on your homework, but it tells me row 1 is unaffected. We copy it in directly. 103. Now we'll do the operation. Let's go carefully. This is a lot to visualize. Take row 1 minus row 2 and just go column by column by column. It'll be 1 minus 1, 0. You have to go in this order, row 1, then minus the row 2 entry. So 1 minus 0, just a 1. 4 minus a 3, just a 1. At this stage, we are done. We just have to interpret what we got. Any questions, folks, to getting to this stage of the row reduction? Okay, here's where we have to do a translation layer. I keep referring to synthetic division because it's a great analogy. We first started by taking the system of equations up here. Let me zoom more appropriately. And we translated it into an augmented matrix. We just cared about the coefficients. We did some interesting row operations, which we're going to practice in a lot more detail next class. But once we go over here, we need to translate back into the fact we're dealing with a system of equations. Here's where the description x1, x2 might be helpful once again, because all we're going to do is read this out row by row, where the dashed line here, highlighted in yellow, is just a reminder of equality. Row 1 says 0 times x1. We ignore that. That simplifies to plus 0. Plus 1 times x2. Well, 1 times x2 is just x2, so we write it down in simplified form, equals 1. This is exactly what row 1 conveys, translated down. We translate down row 2 the same exact way. Lost my red dot. Row 2 says 1 times x1 plus 0 equals 3. So we simplify and just write x1 equals 3. But then we're back to the same exact description. So this is a big preview to what we're doing quite a lot in chapter 1. Really throughout the whole course, we do loads of row reductions, even in places where it's surprising it even came up, for example. And this is a really good introduction of what we're getting into. We'll look at the full process when we come back next class, bigger systems, 3 variables, 4 variables, and so on, and even some unknowns for coefficients. But any questions or comments whatsoever, folks, with what we got to so far today? Okay, I went a little farther than I wanted to. Sorry, sometimes it These things take a little bit more time than what I would have guessed. We were supposed to end a little bit sooner, but we'll make this our stopping time for the day. Pretty much what happens at the end of every single class is I take this, convert the file to a PDF, go back over here, first opportunity I get, re-overwrite it. Then I go to the YouTube studio and I put our lecture into the record lectures here. Sometimes it can take a minute to show up, but it's always going to end up into this place. Well, if you have any questions, feel free to stick around. Pretty much what happens after this is I take a short break myself. My office hours are going to be back in this classroom and on Zoom if you participate online from 4:15 to 5:15. So if you have questions, feel free to stick around a little bit later or just pop in around 4:15. But have a great afternoon, folks. Linear algebra is a pretty interesting subject. It feels pretty abstract at first. Well, it is abstract in all honesty, but it's an interesting set of ideas and systems that come together in a really satisfying way. It's a different kind of match force, but practice makes perfect. I find that people who are doing really well on the homework do really excellent on the exams as well. So if this seems abstract, just make linear algebra one of your priorities on homework, and we'll get through this together. But have a great afternoon, folks. I'll see you all on Thursday. Sure.